My name is Kasia Rachuta, and I will talk to you today about overcoming A/B testing challenges and pitfalls. So, what am I going to go through? We're going to do a bit of an introduction. We're going to talk about what is A/B testing. We're going to talk about the design of an A/B test very briefly. And then we will talk more about the pitfalls that I mentioned and some best practices that we can use to overcome those. So, why am I delivering this talk and what it is about? So, I hold a master's in theoretical physics from University College London. I currently work at Square as a data science tech lead within the identity verification space. And previously, I worked at Medium and 5 Stars. In my spare time, I'm interested in literature, I like baking, and scuba diving. So first of all, what is this talk not about? So I will not be talking to you about multi-armed bandits. I will not be talking to you about frequencies versus Bayesian statistic trade-off. There's plenty of resources about that online. Discussion continues. I will not be talking about specific A/B testing tools. There's plenty of out there. They are outside of scope of this talk. And I will not be talking to you about A/B testing alternatives. So I will not be covering any causal inference techniques here. So what is A/B testing? So it's a randomized controlled trial, kind of like we see research being done in, for example, medicine or in academia. And whenever you Google what is A/B testing and kind of want to learn about some basics, you hear about this experiment about whether users are more likely to click on a red versus blue button. This is like a very cliche toy example. We don't really use that in real life. So you will be testing different pages, removing fields, things like that, but it's unlikely that you will actually be testing the color of a specific button. Or it's also unlikely that this would make a difference to people. So why would you run an A/B test? Well, it's an industry standard. It's the gold standard for proving causality. You can quantify impact of the changes you make on the business metrics very easily using an A/B test. You can also manage risk. So for example, when you are rolling out a change that you are not sure if your users will like, for example, you need to do it for compliance reasons or anything like that, this will help you to also quantify any negative impact that may happen. So A/B testing isn't always just used for quantifying positive changes or trying to win with a variation. And it's extremely versatile. You can use it on emails, buttons, pages. We can go on for a while. So there's a lot of places where A/B testing is appropriate. Oops, something went wrong with my slide. So what are the disadvantages of A/B testing? Well, there are things that can go wrong. So you need to have some time to run an A/B test. If you want to roll or if you have to roll out a change or do something tomorrow, A/B testing is not appropriate. You need to run it typically for at least a couple of weeks. There is an overhead, both from the engineering side, from a data science side. There is resources that are needed. You may need to invest in a tool or an in-house platform for running regular A/B tests. And finally, you need a baseline. You need a baseline metric that you are trying to move. So if you are rolling something out from scratch, and if you have no idea what your baseline is, you cannot really run an A/B test. Because the whole point of A/B testing is that you are trying to quantify a change to an existing metric. So I'm going to very briefly cover design, and then I'll go into challenges. What do you need? You need power, typically at 80%, p-value, typically at 5%. We need the primary metric, so the baseline that I have already mentioned that we're trying to move. And then you also want to quantify what the impact that you want to detect. So for example, if our conversion rate is 80%, which is already really high, do we, for example, want to detect a 1 percentage point difference, 5 percentage point difference? You need to know roughly for what change you are shooting with your product updates. So based on that, you can then calculate your sample size, and then you know how long you need to run your test for. So there's plenty of trade-offs during the A/B testing design phase. So for example, if you want to detect a really small difference, you will require a much smaller sample size. That also means that you will have to run your test longer. That means that you can either do it when you have a lot of users, or you may need to just run it for a while. The question is, do you want to be running an A/B test for something like 8 weeks? Usually a product manager would say no. So that's something worth thinking about. Often in my work, I actually designed a table for our product managers saying, hey, if the difference is 1 percentage point, this is how long we would need to run it for. If it's 5, this is how long we need to run it for. If it's 2, this is how long we need to run it for. And that way they can help us decide what is appropriate for our test. So again, what happens if you need to make a decision quickly? The other question is, how expensive is it to roll out the experience? Can it be actually A/B tested, or is it just so expensive that we're rolling it out anyway? If you ever want to do a lower p-value, which I haven't seen done very often, but it may happen, again, you will need a larger sample size, and you will need to run the test for longer. And then if you have an even split, so for example, you don't want to run it for half of your users, you want to do something like 1090, you need to make sure that the smaller group also hits the right sample size. So a real life example, not the color of a button, but we want to change the sign-up flow for our websites, and we want to check if removing some fields from the sign-up flow will reduce friction, and whether that's going to improve our conversion flow. So this is a statistics example. So we have the null hypothesis that removing a field is not going to change the sign-up rate, and then we have alternative hypothesis that we try to prove here, that removing a field is going to improve the sign-up rate. So now I'm going to talk about pitfalls and what can go wrong. So first of all, you want to really define the business problem that you are trying to solve. You might have a hypothesis, but it's really important to tie it to the actual business impact and the problem that you're trying to solve here. So for example, in our case, it would be users encounter significant friction while signing up for our product. Sometimes the problem statement may be very similar to your hypothesis, or they may be just straight up overlap. But sometimes you just need to make sure that you separate them both and think about the business problem. So what are your launch criteria? So we have the primary metric that we already decided on and talked about before. That's the main thing that we want to change. But there is also a concept of secondary metrics and guardrail metrics. So secondary metrics would typically be metrics that are similar or related to your main metric. And you want to keep an eye on them and also make sure that they let you also verify whether they have moved in the same direction as the primary metric, because typically they should move in a similar way. And then there's also a concept of guardrail metrics so that you can check if something's going terribly wrong. So for example, what if you are improving the number of users, the onboarding rate, but actually you broke something else in the experience? At that point, would you roll back the experience? So that's why it's important to make sure that we have those guardrails in place. One thing that I found often be a conflict of interest between data science and product management is, well, what do you do if the results are neutral? So that's really important to define ahead of time, because as a data scientist, if the results are neutral, I often want to say, no, let's not roll this out. This isn't great. Product management may still believe that this is either a better experience for the user, or it may be something that the design team has decided they want to do. So it's important to align on that ahead of time so that you avoid conflict later down the line. And one other thing that a lot of people don't think about, we have our primary metric. We see whether it's moving up or down or whether it's neutral. But a lot of time, it's really useful to think about what it is that we can learn about our users from this experiment. So for example, are they clicking on a particular part of the flow? that we introduced some extra fields, so the opposite of the example that I brought up here. And are those fields more counterintuitive and people are not understanding what they mean? So there is often some useful learning that we can take away from our test, and then we can propose to run a different test or any other product initiatives that may happen. It's also important to not have a laundry list of different questions that we can answer. With data, we can often keep on going forever. So it's important to also think what can make an impact to the business, what would be worthwhile to know so that we can drive business decisions. So this is my pet peeve. When a product manager comes over and says, hey, can we get some directional data? Well, the question is, what are they going to do with the directional data? And I've had different instances and outcomes here. So sometimes a product manager wants to roll out the experiment right away with a day worth of data or a couple of days worth of data, which as data scientists, we know is not a good idea. Sometimes they just want to check if the data is coming in, how things are looking. They're just curious, but they're letting you run with it. So in my career, I've seen two options of what we do here. The first one is, my preferred one, is we educate our stakeholders. We explain why we need to run the test for a certain time, or we reach the agreement ahead of time that even if we're looking at the results throughout the duration, we will still let it run to the end. I've also, in one of my previous jobs, we actually hid the results from our stakeholders up until they were ready and statistically significant and run for the expected amount of time. That is not great. It doesn't build trust. It's never good to hide things from your stakeholders, but sometimes you may need to do it. So another thing that may happen. So we see that 70% of our users are in the test group, but we really wanted 50%. And 70% is quite extreme. A lot of the time it happens that it's 52, 48, that kind of split. So ideally, you find a sample ratio mismatch calculator online. Make sure that the groups don't have a big difference between them. But once you confirm that actually there is a sample ratio mismatch, you need to start digging more into the data. So one way is to make sure that everyone is in one group, and that one happens a lot. And you will often see that users are matched both to control and test. So how do you set up an experiment to make sure that everyone is only in one group? And one thing that I've also encountered challenges with in my career is sticky feature flags. So for example, if you're rolling something out and a user abandons the experience, you want to make sure that they come back to the same page, to the same experiment group as they were initially assigned to. And that's really important to ensure with engineering. So timing, that's another important one. So seasonality. And I have some holiday gifts here, but that may also mean weekday versus weekend. At different companies I've worked with, we've seen very different usage and sign-up patterns. And for example, right now we're entering the holidays. This is the time when people are shopping a lot more. So if you're working in e-commerce, you will likely see some very significant trends around this time of the year. So what do you want to do? Ideally, you would not be running any tests because they may inflate your metrics, and you may accidentally roll out something that actually is not very impactful to your users. So obviously, to prevent that, you want to make sure that you look at your historical data, you know your trends, you know your users a little bit better than just having the baseline metric from the past month. And you can, that way, quantify whatever impact that may be from seasonality. Another one is, so for example, we are monitoring our metrics over time, and initially we see that the metrics go up, but then they drop. And the question is, do they drop back to the pre-experiment level, or do they drop even lower? Those two may potentially be separate problems that you want to look at differently. So if you have heard there is something called a novelty effect. So sometimes users may be interested in something and clicking something, interacting with something just because it's new on the website, on the page, on the dashboard they normally interact with, not because it's actually useful. So a good way to check for that is to just look at new users and compare that between the groups. If the metrics are dropping to before the experiment level, you need to check your tracking, you need to check your ETLs and make sure that you are actually getting the correct data. You may also want to check which date those metrics started to drop and see if there were any significant or insignificant engineering rollouts that could have messed up your experiment. That actually has happened to me in the past. So you would run kind of all the normal checks that you would do on your typical metrics whenever something has significant movement up or down. Another one. So we want to run a test with multiple experiences. So if you want to run multiple experiences, we know, and there is research that you can read about online that proves this, the chances of having a false positive are a lot higher. So one way to deal with that is to use a naive approach of doing Bonferroni correction, where you divide the p-value over the number of groups you have. So if we typically use p-value of 5% and we want to do 3 groups, we divide that 5% by 3. That means that the p-value we're using is a lot smaller, and again, we will need a much bigger sample sizes for that experiment, and we'll likely need to run it for a lot longer. So what you can do is you can also run the experiment sequentially. So, for example, do A, B, then B versus C, or A versus C. That's also not ideal for the business because that just delays the time to roll out further. So you really want to be cautious and think about how you're rolling things out and what's really worth testing. This one happened to my mentee. So she comes up to me and says, hey, my product manager says that they've rolled out this experiment and whether I can analyze this for them. Turn out that we didn't even know if users were properly randomized because there was absolutely no tracking. The one best single solution is involving data scientists from the get-go. So I set an expectation with all of my stakeholders that they involve me and my data science partners from the get-go. So when they are designing the experiment, and that we're working very closely with engineering to make sure that there is proper tracking, proper setup, anything like that. Otherwise, that's just not going to work. So what happens if you have users in multiple tests or experiences? So obviously, that's not ideal. You would want to, the easiest thing in a vacuum is to just have users in a single experiment at a time. However, the reality is that sometimes you may need to test and have users in multiple groups. So you could make sure that you run only one test at a time. Again, that may slow down the business. Or you could use something like linear regression to quantify the impacts from different experiments on the user. And there was recently, I've seen a number of interesting blog posts that talk about how to quantify that and how to move faster as a business with users. Another one is writing ad hoc queries for every single test that you run. This is incredibly annoying and time-consuming as a data scientist. So ideally, what you want to do is you want to have some sort of reusable dashboard. Chances are that you are running a number of A/B tests, and usually you are trying to move a couple of the same main metrics. And for those metrics that you are using over time and testing over and over again, you can build something reusable. I've done that in a BI tool, so something relatively simple, but there's also specified tools that specialize in running those calculations and making sure that there is a reusability to each test so that you're not just spending the same, a lot of time doing similar work over and over again. So some best practices and some closing thoughts. shameless plug here. What should you do before you start an experiment? Ideally, you should have a template that you fill out with your stakeholders. There you can talk about the business problem, the hypothesis, primary metrics, how long you want to run the test for, what users you want to be running the test on. So is it only desktop users in the US? Are there any other markets you are targeting? Are you targeting different platforms? This list can go on, but it's important to specify that ahead of time. And I publish Square's experimentation design template, so you can use this tiny URL to get your own copy if you want to reuse that for your own purposes. And lastly, it's important to think about including things like links to PRDs, engineering design docs, in your experiment template. Also including screenshots or Figma links so that you know exactly what you're referring to. For my team, we also have an A/B testing tracker. It's very simple. It's a Google Sheet. There we put down when we start the test, when it's meant to end, who is directly responsible individual for it from the data science side, who is the product manager that's interested in the test. And then we also include whether we've rolled out the test or whether we rolled it back. And that's also where we include the post-experimentation analysis. Some resources, I don't know why one of them got crossed out, but this is not because I changed my mind about it. I still think it's very good. So Trustworthy Online Controlled Experiments is a gold standard book in the industry, strongly recommend it. I also recommend you buy your own copy because it's constantly in use from the library in San Francisco. And then there was another really good article that I've enjoyed is How Not to Run an A/B Test from Evan Miller. He also has a lot of tests that help, a lot of tools that help you calculate sample sizes or even run chi-square tests, t-tests very easily. So strongly recommend that. Thank you.